Today, I'd like to spend a little bit of time talking about recursion. Usually, recursion is something that people find difficult. It's a different way to reason about iterating through lists, or it's a different way to think about reaching base cases. And generally, I expect that most of you are much more used to imperative style, where while loops, for loops, and the such are what you would turn to first. Now, recursion is not something you should think about as being incredibly difficult or scary or worrying. It's something that allows us to do really the same things as you would with a for loop or a while loop or whatever you might use, but just in a way that allows us to reuse the code that we've already written. So you really shouldn't see it as anything more than that. You should see recursion as a tool to use when you see I've defined all of the cases and then I'll just recurse because I want to reuse all the work I've already done. You should try not to see it as anything more than that. So today I want to show you just a little example about how we would translate a while loop, a very simple function on how to calculate the greatest common divisor of two numbers. You don't really need to worry too much about what the greatest common divisor is. It's just an example of an algorithm that we can translate into Haskell using recursion. So you can see up here we've got a couple of cases. So we say that while A and B are different, then if A is greater than B, we take B away from A. Otherwise, when B is greater than A, or when B is greater than A, we do B equals B minus A. And then we return the value of A at the end of this when they are now equal. So we subtract and subtract and subtract until they're equal, and then we return the value, and that's how we find the greatest common divisor. Again, it's not tremendously important that you worry that you understand how this calculates the greatest common divisor. The main thing is just to look at the algorithm, understand what it's doing, and then see how we translate this to Haskell. Of course, as I say, in declarative languages, we don't really have explicit loops, so we won't be able to do a while statement here. What we will do is we will use recursion, and hopefully you'll see that it's quite a simple way to define the same algorithm. So let's get started. Now, of course, this is something that takes two integers and returns an integer, so our greatest common divisor should take an int, another int, and it should return an int, little lowercase letters. And let's call them the same thing, so let's call them A and B, and we start off with an equal, and then we'll think about how to do this. The first thing I want to say is that when A and B are equal, I just return the value. Now that's one thing that Haskell will make a little bit clearer in this example than the while statement up here does, because you immediately are confronted with while A is not equal to B, then you do this stuff, and it takes a little bit of time to figure out that when A is equal to B, we do just return A. That's obscured by the fact we're using a while loop here. So what I'm going to say is I'm going to use a guards to complete this, and I'm going to say that if A is equal to B, then I return A. Now again, I don't need a return statement in Haskell. It's sufficient just to say when A is equal to B, then this function equals A, and that's all the computation done. I just return A. So that's what's happening there. Oh, no, I don't want that suggestion. Apparently Visual Studio thinks I don't know what I'm coding. So then I'll need another case because I've not completed all of the algorithm yet. So what happens when they're not equal to each other? Then I say if A is greater than B, so I can just copy that directly into Haskell. That's very straightforward to do. I can try and line these up just so it looks a little bit tidier. Then I do A equals A minus B. Now in Haskell we can't mutate state. That's something that's very different in Haskell than it is in other languages. We can't mutate the state. All we can do is call functions on arguments. So what I'm going to do is I'm going to use a recursive call with updated parameters. And that's really what's happening in this while loop, because while A is not equal to B, you just keep doing this loop over and over and over again. So that's how I'm going to that's the same way that I'm going to use recursion. So if A is greater than B, I know that I need to go through this loop again, and I need to update the value of A. So what I'm going to say is greatest common divisor, and A is my first argument, so I'm going to say that the greatest common divisor is going to take a new argument, which is A minus B. Now this isn't updating the state of a variable, this is just performing subtraction to get a value for this greatest common divisor function. And in this case, B does not change, so the second argument of the function should be B. So that's two of the cases done. Now they're in the else condition. And what I can do here is I can just say otherwise this will be equal to the greatest common divisor of something. And I'm going to line these up because I prefer to line up the equals statement in my functions. So then I do b equals b minus a, and I can use a similar trick to what I just did, where I do b minus a, like that, and I'll space these out a little bit. And that should be me. I don't know why I'm getting an error here. It's because this already is defined, so let's call this GCD1, and these ones can be GCD1 as well. So that's just because there's already a GCD function in Haskell, so that's why I was getting that error. So now this should be fine, and I'm going to line these all up again. Now, before I run this code, let's just look at what's happening here. All that's happening with these recursive calls is I'm defining the same behavior in the while loop. So really, you can look at this recursive call here and see this as just jumping back to the start of the while loop. And this is what I mean by it not really being that different. It's a different way to reason about things, but you're really implementing the same logic by using recursion. So I don't want you to see it as anything that should scare you. Even if you find recursion difficult, you're going to get a lot of practice of it in this class. It's a very useful tool to have in your mind. It provides you with a different way to think about and solve problems, which is invaluable no matter what you wind up doing. So these are just doing this logic. This is not different from this. They're doing the same thing. So let's see how this works, or if it works even. So I've called it recursion. I've got an error in here, and that's because I didn't save before I loaded. Actually, I can just recall that. There we go. Compile main. So let's see. For example, if I give it 4 and 5, the greatest common divisor of them should be 1 because 5 is prime. So let's do 4 and 5. 1 is fine. Let's say I do greatest common divisor 4 and 6. The divisors of 6 are 6, 3, and 2, 1. Divisors of 4 are 4, 2, and 1. So the greatest common divisor of 4 and 6 should be 2. So we're happy there. If I give it a bigger example, let's do 50 and 25. They're both divisible by 25, so that should certainly be the greatest common divisor there. And there we go. So the greatest common divisor function works. We're using simple recursion. We're just updating the arguments as a way to avoid having to update variables because we can't do that. And that's all that's happening here. So really, all I want you to take away from this video is using recursion can be very straightforward and very simple. It's really just a way to reuse the logic that you've already defined. So it's a way to take work off yourself. And it lends itself to a very simple definition. I personally think that this is a much clearer function than this. You're of course welcome to disagree, but it's a very straightforward function where you have each case and then the behavior that happens in that case. So that's everything for today. I hope you found this useful. Of course, if you have any questions, you're more than welcome to get in touch. Thanks.